Hello everyone, I am Dr. Amit. Welcome back to our pharmacology series. Today we are going to talk about Michaelis-Menten kinetics. Okay, so we'll make it incredibly simple and we'll break down the curve. Okay, this curve, and we'll look at different conditions at which how this curve get affected. Okay, and we'll see how different inhibitors change the game. Okay, so before we jump into the lecture, please make sure to subscribe to my YouTube channel so you don't miss out any medical basis. So let's get started. So our today topic is Michaelis-Menten kinetics. Okay, so first let's look at the enzyme kinetics. Okay, so we'll talk about Michaelis-Menten. We are looking at this hyperbolic curve. Okay, so this curve is hyperbolic. Okay, so first I will try to explain this diagram first. Okay, so this is your x-axis and this is your y-axis. Okay, so this x-axis denote the concentration of substrate. Okay, so this is S. Okay, and this y-axis define the velocity of the reaction. Okay, so here we have written the Km. Okay, we all know Km is that concentration of substrate where the velocity of reaction will be half of the maximum velocity. Okay, so this is the concentration. Okay, this point where the velocity of the reaction is half of the Vmax. Okay, now while talking more about this curve, okay, so many MCQs are asked from the behavior of the curve. Okay, so so the shape of the curve is hyperbolic. Okay, now we can see that initially the reaction is fast. Okay, it's increasing. Okay, now later it slows down. Okay, later it slows down and finally it reaches a plateau stage. Okay, and this plateau stage is Vmax. Why we are calling it plateau stage? Because after this the reaction rate is not increasing above, it's going straight. Okay, so this is where there is saturation of the Vmax. Okay, so this is the level of Vmax. Okay, so while talking about the behavior, the shape is hyperbolic. Initially the reaction is fast, then later slows down and finally it reaches the plateau stage. Okay, now we'll talk about some important conditions. Okay, like when the substrate is low. Okay, the concentration of substrate is very low than the Km. Then we'll talk about high substrate, when the concentration of substrate will be very high in comparison to Km, and we also see a condition when a substrate is equal to Km. Okay, so let's see one by one. So if the substrate is very low, okay, so if when the substrate is very low, then the enzymes are free. Okay, in that conditions the reactions depends on substrate. Okay, and it follow the first order kinetics. Okay, like if the substrates double, the velocity double. So let's understand it with a figure. So let's understand with this figure. Okay, suppose this is an enzyme. Okay, these are the active sites of enzyme. Okay, now we have only two substrate. Okay, so this substrate will come in this side and this substrate will come in this side. Okay, still there many rooms are free. Okay, so if we'll double the substrate number, okay, if we'll increase the substrate number, suppose more and more substrate will add over here. Okay, like more and more substrate will add over here, then the reaction rate, the velocity of the reactions will double. Okay, so that's why we say that if the level of substrate is low, then if we double the substrate, then the velocity double. Okay, and this reaction depends on the substrate level and it follow the first order kinetics. Now we look at when the substrate level is high. Okay, so when substrate is very high, enzymes fully saturated. Okay, so enzyme fully saturated, it follows zero order kinetics and the velocity is constant, no effect after increasing substrate level. So now again let's see with the figure. Now you can see in this figure that the enzymes rooms are already occupied by the substrate. Okay, there are no vacant room. Okay, so no matter if we add more substrate, okay, but there is no room for this substrate. Okay, we can't add this substrate. Okay, so the velocity is constant because we can't increase the reaction velocity now, even if we'll increase the substrate level. So it's written that velocity is constant, no effect after increasing substrate. Okay, so this is how high substrate level affect the reaction. Okay, now we'll talk about at S is equal to Km, when the reaction is balanced. Okay, so at that time V is half of Vmax. Okay, so this we are talking about this figure. Okay, when the substrate concentration is Km, so then the velocity of the reaction will be half of Vmax. Okay, now we'll compare this figure with different inhibitors. So let's link this with the inhibitors. Okay, so we have competitive inhibitors, non-competitive inhibitors, and on-competitive inhibitors. Okay, so while talking about the competitive inhibitors, okay, we all know inhibitor competes with substrate for the active sites. Okay, and in this condition the Km increases. Okay, need more substrate to reach the same velocity. Okay, and the Vmax remain unchanged. Okay, so this most often asked in the MCQs is what happened to Km and what happened to Vmax in competitive inhibitor. So Km increases and Vmax remain unchanged. Okay, so we'll understand these two with a figure. So suppose these are the active sites of the enzyme. Okay, these are the substrates and these are the inhibitors. Okay, now the substrates want to come here. Okay, but this inhibitor will fight with this substrate. No, I want to sit in this room. Okay, suppose this want to come here, now again this want to come here, now this will inhibit this, fight with this, that I will sit here. Suppose this will fight with in this room with this enzyme. Okay, so we can see that this competitive inhibitors are fighting with the substrate to get the room. Okay, so in these conditions we need more and more substrate, okay, to fight with these inhibitors. Okay, so that's why need more substrate to reach the same velocity, because they are inhibiting this substrate to get into this room. Okay, but the Vmax will remain unchanged, because if there are enough substrate, no matter how much inhibitors will be there, the reaction of the speed will remain unchanged. Okay, so this is all about competitive inhibitors. Now we'll talk about non-competitive inhibitors. Okay, these inhibitors bind on different site on the enzymes. Okay, they will not compete with the substrate, so enzyme become partially inactive. Okay, the enzyme will become partially inactive, and in these conditions the Vmax will decrease. Okay, the plateau of the graph will lower and the Km remain unchanged. Okay, again we'll understand with this figure. Okay, so suppose this is the enzyme. Okay, these are the active sites of the enzyme and these are some other sites, inactive sites of the enzyme. Okay, so when this non-competitor, suppose this is a non-competitors. Okay, and these are the substrate. If the non-competitors, these non-competitors will not fight with this substrate, suppose this will come and sit anywhere on the enzymes. Okay, suppose this non-competitors will come and sit in these rooms. Okay, so after sitting in these rooms, they will partially inactive this enzyme. Okay, they will make this enzyme slow. Okay, so in these conditions what will happen? If the enzyme will become slow, then the Vmax, okay, the Vmax will decrease, the Km will not change, but the velocity of the reaction will decrease, Vmax will decrease. Okay, Km will remain same. Okay, now we'll talk about on-competitive inhibitors. Now in case of on-competitive inhibitors, okay, the inhibitors binds to this enzyme and substrate complex. Okay, so suppose this is a on-competitive inhibitors. Okay, so they will not do anything, they will just form a complex, okay, by binding to this. Okay, and this will result to decrease in Km and Vmax both. Okay, so these are the conditions from where most of the MCQ asked in the exams. Okay, so just try to remember in which conditions Km increase, in which conditions Vmax increased, in which conditions both decrease. Okay, so just try to mug up all this and try to understand with this figure. And that is Michaelis-Menten kinetics in a nutshell. Okay, I hope this helps you in your exams and clinical practice. So thank you for watching. If you found this helpful, please like, share and subscribe. See you in the next video with line weaver buck plot. Okay, thank you.